Okay, so we start with transfer function. Okay, what is transfer function? By definition, transfer function is the ratio of the Laplace transform of the output signal to the Laplace transform of the input signal. Okay, Laplace output over Laplace input. This is what we call transfer function. Okay, for example, in this, okay, GS, okay, Laplace. So Laplace means that we use in S domain. S domain, or we call frequency domain, complex frequency domain. S is complex frequency. S equal to sigma plus j omega. So complex frequency domain. S. Okay, G. G for transfer function. G. Transfer function. Sometimes we call G for gain. Gain means that a system gain output divided by input, we call gain. Output, let's say for this example, we use Y as the output. Input is U. So all the equation in S domain. So output, Laplace of the output over Laplace of the input. This is what we call transfer function. Okay. For example, okay, we have the system. We have system. Our system, and then here we call GS. This is our system gain, input and output. So output divided by input. This one divide input. This is what we call G. Is equal to G. Input divided by input is equal to G. Output divided by input equal to G. Okay. Any question? This is what we call transfer function. Okay, from general equation, for example, we have very long equation, A, Y, and all this part Y equal to this part U. So this part is input, this part is output. Okay. For example, this, let's say we have, this is differential equation. Equation. Okay, this part is term, for this part is Y. Okay. Look here, all the Y. And for this part is U. Okay, U is the input, output is Y. So we have to rearrange all this equation become Y over U. Just rearrange it. Y over U is G. This is a transfer function. Okay. So this one B A. Okay. Y over U. So all the B. So this part B. This part is A. So A. Sorry. B. A. Okay. This one is the general transfer function equation. Okay. So we will try to do one example. One example is RL circuit. We have RL circuit here. RL circuit. So this part is input part. This part is output. Okay, we have R and L circuit. So what is transfer function? It's equal to Laplace of output divided by Laplace of input. Okay, for this circuit, our input is voltage, output is input voltage. This one is output voltage. So that means the transfer function is, for example, GS is equal to V out S divided by V in S. Okay. Any question? Before we derive it?
No, doctor.
Okay. Okay, good. Okay, now what is V out? What is V in? So we can use we call KVL. KVL, Kirchhoff voltage law, at this part. KVL. KVL. Okay, KVL. What is KVL? Kirchhoff voltage law. Voltage law mentioned that total voltage in a closed loop. Okay, this one is closed loop. Closed loop. Total voltage in a closed loop equal to 0. Okay. So total voltage in closed loop equal to 0. Okay. In this loop, we have this voltage V1, voltage at R, and voltage at L. Okay, we have three voltage. So voltage at V1, input voltage at VI, voltage drop at resistor, and voltage drop at inductor. Okay, total voltage there. Total of all these three voltage equal to 0. Okay, what is VI? So we do KVL here. KVL here. So minus VI. This one is current flow here. So means that this one will be positive. This one also will be positive. Plus, okay, in this case, our current is I. IT, T domain. T domain, input voltage, ITR plus. So in this case, we have inductor. Voltage at inductor is equal to L di over dt. Okay. Voltage at inductor is equal to changes of current here. Changes of current times inductance. Okay, L di over dt. So plus di over dt equal to 0. Total voltage equal to 0. So 0 volt. Okay tak? Boleh ikut tak?
Boleh, doktor, boleh.
Boleh,
Boleh,
sir.
okay. Boleh, we'll proceed. So, okay, now we rearrange it. It will become, okay, next is our V naught. So we want V out and V in. So what is our V out? V out is here. Okay, V out is there. So V out equal to voltage drop at VL. Okay, V out kat sini. Just parallel kan, parallel. V out parallel with inductor. So V out equal to VL. Buat kat sini lah. V out equal to VL equal to L di over dt. Okay. So now VI, this one is VI. Okay, V out here. V out is equal to L dt. So we can replace V out here. Okay tak?
Okay.
Okay, tak apalah kita buat one by one. Okay, no need to replace that. Okay. So V in equal to rearrange. Arrange V in equal to, so now negative become positive. So ITR plus LDI over DT. This one is V naught equal to LDI over DT. Okay, now we Laplace it to, this one is in T domain. So we know that transfer function is in S domain. So we have to convert to S domain by using Laplace transform. And we Laplace it, Laplace VI is equal to Laplace ITR plus Laplace LDI over DT. Okay, that is for this part. For this part, Laplace V naught equal to Laplace LDI over DT. Okay. So VI, what we get is, we Laplace it, it's still VI juga lah. But now before this it's T, it's T, yeah. So now VI S domain. This one is IS domain times R plus L. This one become S I S. One. So for this part will become VS equal to Laplace L similar as the one L S I S. Okay, this is number 2. So finally, for transfer function equal to GS equal to V out over V in is equal to, so V out is here, equation number 2 divided by equation number 1 equal to L S I S over I S R plus L S I S. Okay. Then we can simplify it. We can S, so I, okay. Then finally our transfer function is equal to LS over R plus LS. This is transfer function. Okay. Any question?